Forget everything you thought you knew about insulation. In a monumental leap forward, we're asking, what if foamed concrete became the ultimate insulation material? This isn't just a hypothetical thought experiment. It's they look into a future where buildings are stronger, more efficient, and perhaps even more sustainable, all thanks to this innovative material. Imagine your walls being insulated in their own right. No more filling them with glass wool and attaching extruded panels. Foamed concrete, a material as light as wood, as strong as stone, and more insulating than cotton, is making this imagination a reality. If building could be as simple and efficient as building blocks, would we still need traditional insulation? Engineering a new world. The integrated building revolution. The core breakthrough of foamed concrete lies in SQUATURAL, insulation integration. Work process streamlining. Single pouring replaces the traditional wall plus insulation layer plus plaster layer, shortening the construction cycle by more than 50%. Performance integration. The density of 500 kilograms per cubic meter foam concrete. Compressive strength of more than 5 megapascals. Thermal conductivity of only 0.1 West mK. Both load, bearing, and thermal insulation function. Designed for liberation. Plasticity supports curved surfaces and shaped structures. Realize, NG, a seamless enclosure system without thermal bridges. Social ripple effects. From cost to urban change. This revolution will reconfigure the ecology of the industry. Cost reversal. 30% reduction in the overall cost of aerial self-build home, and a 60% saving on heating costs. Employment shifts. Traditional insulation. Construction jobs are down, but new jobs such as precast, foamed concrete, and 3D printing are growing. Industrial upgrading. China has enterprises to achieve an annual output of 500,000 cubic meters of foamed concrete panels, leading to the development of the equipment manufacturing industry. The environmental benefits are significant. Lower implicit carbon. Using industrial waste materials such as fly ash, the carbon emissions per cubic meter are 120 kilograms less than traditional wall systems. Urban resilience enhancement. Class of fire protection plus seismic performance for climate-resilient cities. Housing affordability. Rapid construction has brought down the cost of secure housing, and Brazil has built 60 square meters homes in 7 days using foamed concrete technology. Challenges and concerns. A rational view of technological disruption. Challenges still to be overcome. Humidity management. Tropical areas need to add a moisture barrier to prevent capillary water absorption, leading to a decline in insulation performance. Strength and density balance. Low-density models below 300 kilograms per cubic meter cannot be used in load-bearing structures for the time being. Lagging standards. National codes do not fully cover integrated walls, and acceptance relies on special demonstrations. Disruption is inevitably accompanied by pain. Interest pattern breaking. The traditional insulation material industry chain annual output value of more than 100 billion. The transformation needs policy guidance. Skills gap. Existing workforce needs to be retrained, and developed countries have introduced specialized vocational certifications for foamed concrete. Supply chain reconstruction, foaming agent, special equipment, and other upstream industries need to be standardized. Foamed concrete is not a panacea, but a key piece of the jigsaw puzzle for the industrialization of construction. When we replace complex insulation systems with a single block of breathing stone, We save not only energy, but time, resources, and the planet. It's a revolution that requires the rigor of engineers, the wisdom of policy, and the courage of the marketplace, because the best buildings should be as simple as nature.